Today we're going to talk mixed fractions and complex fractions. We'll start with the mixed fractions. Mixed fractions is defined as one term that's basically a whole number or an integer value, and the other term has a numerator and denominator associated with it. This integer value, while it looks to not have a denominator, they all have denominators, and in this case, as in every case, it's going to be 1, so we have to find a common denominator between the two of them. This first term, we'll need the full 5 plus 2x, so I will rewrite that just like I've been doing all along in both cases. And the 7 gets multiplied by the 5 plus 2x, both in the numerator and denominator. This gives us 35 plus 14x. Subtracted by 4 minus 3x. Again, I like to rewrite 35 plus 14x minus 4 minus 3x over my LCD, which is 5 plus 2x. We know this is like this invisible 1 that I'm going to have to distribute through. So I get 35 plus 14x minus 4x, or minus 4, sorry, plus 3x over 5 plus 2x. Combine our like terms, 17x plus 31 over 5 plus 2x. No GCF, so that problem's done. So here we have another mixed fraction. And in this case, we're going to start by making sure we have our denominator of 1 under the second term. Let's get a common denominator. Clear to see that it's just 7x minus 9, so I'll write that twice. First term, no change from this denominator to this denominator, so I just bring down my 2x plus 5. Second term, to get from 1 to 7x minus 9, I need to multiply by 7x minus 9 to both the numerator and denominator. I'm going to need a FOIL here, so I get 14x squared minus 18x plus 21x minus 27. I have to remember to distribute my negative to each and every one of these terms. So I have 2x plus 5 minus 14x squared plus 18x minus 21x plus 27, all over this LCD of 7x minus 9. We're going to add like terms, negative 14x squared, 2, 18, and negative 21, which is negative 1, and 5 and 27, which is 32. Put that all over my denominator of 7x minus 9. I could check to see if this is going to factor here. It's not, so I can be done with the problem. So complex fractions. A complex fraction is just basically a fraction over a fraction. And if we were to read this out loud, I'd have 15 over 8 divided by 3 over 4. Now, when I read it like that, I can write it as we did in probably 5th or 6th grade, 15 over 8 divided by 3/4. And if I write it horizontally, we know that this is just a division of two fractions, which is the same as multiplying by the reciprocal. So in this case, I have 5 reducing here, 2 reducing here. I'm left with 5 over 2, and my problem is done. So if all we really need to do is multiply by the reciprocal of the bottom term, we can simply do that anytime we have a complex fraction. Except this complex fraction is a little more difficult once we start going to algebra. But not so much. We have x plus y over a plus b divided by x squared minus y squared over a squared minus b squared. This is the same, once again, as multiplying by the reciprocal. So I'm going to multiply by the reciprocal, and I'm also going to factor while I do this. So this term goes to the numerator, this term goes to the denominator. I know there's both factor because there are a difference of squares. You have a plus b times a minus b. And we have x plus y times x minus y. And we know that whenever we have like factors, we can go ahead and cross reduce. So I see the x plus y's are the same, the a plus b's are the same, which leaves me with a minus b over x minus y, and I'm done. So again, complex fractions are nothing to be afraid of. You just have to make sure that you're multiplying by the reciprocal of the second fraction. Now in this case, we can take the same approach. We can say x squared plus 2x over x squared plus 9x plus 18 multiplied, or divided by, if you will. We'll write it out the long way first. X squared minus 5x over x squared plus x minus 30. Multiply by the reciprocal, and I'm going to factor while I'm at it. So I pull out a GCF of x in the first term, x plus 2. Second term, what multiplies to 18 adds to 9, that's x plus 6 and x plus 3. I'm going to multiply by the reciprocal, which means I'll factor this denominator here, get x plus 6, x minus 5, and in the second term I have an x in common and an x minus 5. Any like factor I can go ahead and cross reduce. The x's reduce out, x minus 5 top and bottom, x plus 6, leaving me with x plus 2 over x plus 3. So last, we have a little bit of a word problem. She buys 42 3/4 yards of backing fabric, and 2 1/4 yards are needed for each quilt. And you want to know how many quilts she can make using that backing fabric. So basically we're taking 42 3/4 and dividing it by 2 1/4. Well, we can do that a lot of different ways. I'm just going to write it out. 42 3/4. I like doing improper fractions rather than mixed numbers. So let's go ahead and rewrite that. So we get 171 over 4 here. And that's divided by 9/4. Multiply by the reciprocal, 171 over 4 times 4 over 9. 4 is reduced. Just so happens 9 goes into 171 19 times. And I end up with 19. That's all we've got for today. Do these 3 problems, and we'll discuss this more tomorrow.